Hi, and welcome back to another Better Terrain video. In this video I'm going to go over using Better Terrain from GDScript. I've set up some tiles. I've got a grass tile and a brick tile. This is very similar to the first video. It's exactly the same graphics and they're set up in the same way. So if you want to know how to set up terrain, check that video out. But I've updated the project so it can now run. It doesn't do anything, but we can see the tiles on the screen. I'm going to go to project settings. I'm going to search for FPS. Go to debug settings and turn on print FPS. That's going to be useful to see. What that does is it prints out the frames per second down here in the output pane. There we go, 60 frames per second. I'm not doing anything at runtime at the moment, so this is just an empty project running at full speed. Let's start by erasing the stuff I've drawn. There we go. And I'm going to add a script to the example node here. I'm going to be using GDScript. Calling it from C# is possible. You have to use the call command. So that's possible, although it is a bit more fiddly than I'd like. I don't use C#. If anyone wants to make a C# version, the source code for Better Terrain is fully available, so go have fun. But sticking with GDScript for now, let's make a ready function. And we're going to call Makemap. I'm going to Makemap function. The screen is 640 by 480, so I'm going to just define some constants. There we go. That's not a particularly good way of doing that, but it'll work for this. So we're going to iterate it over the whole screen, and we're going to put terrain in each cell. So we want to call Better Terrain set cell. We're going to need to pass in the tile map, which I will make an onReady. So tile map. We're going to need to pass in the layer. I only have one layer, so that's 0. We're going to need to pass in the coordinate, which is going to be a vector 2i. Well, it's just x and y for the screen. And we're going to pass in the terrain type. I only have 2 terrain types, which are going to be 0 and 1. Let's just pass in rand I mod 2, which will be 0 or 1 randomly. Once that loop has complete, we need to do Better Terrain, update terrain. Now we can update terrain cells or an area. Now if you've used Godot 3's auto tiles or some other engines, you might be familiar with this kind of paradigm. First you set the cells and then you call the update function so they're calculated all at once. Well, we're going to update the area, so we need to pass in the tile map, the layer, and the rectangle as a rect 2i that we're going to update, and that's going to go from 0, 0 to, let me just move this down a bit, to screen width and screen height. There's also another parameter which is gonna, if you control click you can see, and surrounding cells, which controls whether or not it updates just the area or the area and the cells that neighbor that area. We'll just leave that defaulted to true. So now if we run that, there we go. We've got a whole lot of terrain. Make this full screen. As you can see, it's matched it all. It doesn't look particularly nice. This isn't a very elegant map generator, but nonetheless it worked. So that's the general idea. Now if you want to do more updates, let's make a process function. In the process function, we're going to pick a var x and make it a rand I mod screen width, and a var y rand I screen height. So that will pick a number between 0 and the width, and for y 0 and the height. Now we want to write better terrain set cell. Again, we pass in the tile map, the layer, which is 0, the coordinate, which in this case is again x, y, and what we want to set it to. Well, we could just once again set it randomly, and this time when we update, we're only going to update the one cell. So we're going to do update terrain cell. It's going to take the tile map, the layer, and the cell, which I didn't store, but I'll just make another one. Right, now if we run that, we should get tile updates happening every frame. Now as you can see, it's still running at 60 FPS. Matching tiles and running the terrain algorithm does take quite some computation. It's only GD script and it is doing a fair amount of calculation, so it's fast, but it ain't that fast. And that's what I'm going to demonstrate now. So let's comment these things out, and instead let's call Makemap inside the process function. So every time it calls process, which is every frame, it will call Makemap and draw a brand new random arrangement of terrain all over the screen. Now if we play that, we can see that's running pretty nice, but you notice the frames per second has dropped right down, so that's not good. I am also screen recording, and this is a laptop. I can hear the fans coming on, so this is not exactly ideal. Well, you might say, well, why are you generating so much terrain? Well, there's reasons why you might want to. A good example would be in a roguelike. You might generate an extremely large level at the start, more than 40 by 30. It might be more like 500 by 500 or something. Or you might update terrain based on the player walking around. For example, maybe they have an effect on the environment around them, which you might want to do through terrain. Not necessarily the best way of doing it, but every game is different, so it's hard to predict what people will want to do, and everything's valid. Okay, so let's look at speeding up Makemap. Instead of setting all the cells and then updating the terrain area, what we're going to do is use the threaded functions of better terrain to run the terrain algorithm on a separate thread and then set the cells when the algorithm is complete. So we're going to make a dictionary called update, and in the update dictionary we're just going to set a bunch of vector2i's for our coordinates to be random values. I'll get rid of this one. So we made a dictionary that contains all the terrain that we want to set keyed on the coordinates. Now we need to call better terrain dot create terrain change set. Now this takes 3 parameters. As always, it takes the tile map and the layer, and it takes that dictionary we just made, and this returns a change set, which is a variable type, It's actually a dictionary if you want to type it. So let's set our change set to that. Creating the terrain set will cause the thread to spin up and it will start running the calculation. We don't need to update the area. So now in the process function, let's get rid of that. We want to say if better terrain is change set ready on our change set, and it's valid to throw in an empty dictionary. Then we want to call better terrain apply terrain change set. There we go. And we can clear it. It's a dictionary, so we can just get rid of it. And we don't want to make the map. So the change set comes out already finished, so we don't need to call the update function at all. And now if I run that, what we should see is that it starts the ready function, makes the change set in Makemap, and then every frame it waits, or it checks if the change set is ready, and if it is, it applies it and clears the change set. So what I want to do now is, instead of clearing the change set, I'm going to call Makemap again. So once it applies the change set, it will immediately make a new one and kick off the thread again. Now if we run that, we can see it's updating just like before, but the frame rate is now stable at 60 frames per second because this is all running on another thread. And my laptop fan is turning on. It's still doing as much work, and indeed the frame rate of the terrain updates isn't going to be 60 frames per second because, as we already saw, it can't complete this entire terrain update within the space of a frame. So it's going to have a lower frame rate on how fast it's updating, but the important part is it does not affect the frames per second of the project, or at least not as severely. My laptop is getting kind of warm, so I'm going to stop that. So the good thing about these change sets is that once they're calculated, you can apply them whenever you want, as long as your tile map is still valid. So you could calculate a few of them at the start of the level and apply them whenever you want. And whilst applying them is not completely free, it does take a little bit of time. It's largely just calling through to Godot's internal functions, so it's pretty quick. The actual terrain calculation, which you call from create terrain change set, is the part that does the heavy lifting, and it does that through a threaded worker pool. That was quite a brief introduction. If you go to better terrain by control clicking on it, you can look at the code. It's all in GD script. The functions that start with an underscore are internal, but there's plenty of functions for doing everything that you can do in the terrain editor through code. For example, you can get terrain details, and you can update terrain cells and replace cells. There is comments. The F1 tool for Godot is a little bit funny. I still can't always get it to show up, but sometimes it will give you the help page with the comments in. If anyone knows exactly why Godot doesn't always do that, please let me know and I'll fix it. I hope this helps, and I hope you enjoy using better terrain. Any questions or comments, let me know. Have a nice day. Goodbye.